Radarsat is a very flexible satellite. The sensor that's on board it is probably world-class. There's nothing really existing today that matches it. And originally the satellite was really conceived on the basis of a lot of activity that was going on in Canada in the frontier regions in the Arctic and off the east coast of Canada, primarily related to oil exploration. So a big focus of the satellite's use was for monitoring ice conditions in these parts of the area. So they would map where the ice was moving, getting a better feel for the impact it might have on oil production or maybe ships transiting through the Arctic. And this picture illustrates the concept a little bit. Basically, you see ice between these green islands, and it's important for the ships to know where they can go through there for sort of optimal routing of the ship. So that was kind of the foundation for the satellite program. But since then, this was back in the early 1980s, and since then a lot of research has been done on potential applications of radar imagery, which is what Radarsat collects.
Now, radar is superior in that you don't have to worry about clouds when you're taking your images, but how else is radar imagery superior over a good old-fashioned photograph?
Well, the two most important things are probably the fact that it can image through clouds, and also the fact that it is sensitive to surface roughness. And that is one of the reasons why radar has been used quite effectively by geologists who are perhaps looking for new mineral deposits or for looking at places where they might want to do some sort of oil and gas exploration. Because the radar is so sensitive to the surface roughness, you tend to see the mountain peaks standing out very clearly. They can use it to detect where faults are, this type of thing. All of the useful information they use in planning where to explore for minerals and oil and gas. So that's a key benefit of the radar.
I understand that Radarsat also has application for agriculture.
That's right, or we think it does. We are doing investigations in this area. One of the things that we're looking at right now is the ability to monitor crops at different stages in the growth cycle. And we've been using some airborne data that was collected by the Canada Centre for Remote Sensing in China. And in this particular illustration, we've got a radar image of an area in China. And among other things, what the image is showing is rice crops at different growth stages. Because of the unique conditions in which rice grows, where initially the paddy fields are flooded and then the crop slowly emerges, it's possible to see changes in the patterns and the textures on the image as the crop matures. So we're hoping that we will be able to time the imaging at the right stages so we can actually monitor the development of crops. Other work is being done in that area in Canada as well.
Okay. Now we have a couple of photos here that were taken in Georgia Strait, and could you explain what these might be used for? And
sure, I can do that. In fact, these are simulated Radarsat images that were acquired using data collected from an aircraft a couple summers ago. And these images were taken in the Strait of Georgia, just off the coast of Vancouver. And there's a number of interesting things that you can see in here. First of all, they're simulations of two of the operating modes that I was talking about. In this particular case, it's simulating what we call the fine mode, which gives you fairly detailed resolution, about 10-meter resolution. This image represents the standard mode, which gives you a little bit reduced resolution at about 25 meters, but covers a wider area, 100 by 100 kilometer square area. You can see some of the features in both of them, but there's typically more detail in this image. But a few things that are interesting here, this bright spot here represents one of the BC ferries that's going between Vancouver and Victoria. And actually you can see a narrow V behind the bright spot. That represents the ship's wake. And so those kinds of features stand out quite clearly under certain circumstances in the ocean. If the weather gets too rough, you tend to lose the signal. But under many of the conditions, you can actually pick out these kinds of targets. Other things that you see include these dark areas in here, which can be related to slicks on the water. In this case, they may be oils produced by kelp beds, but it's the same kind of thing that could be detected if there was a real oil spill or something like that.
Now, the distinguishing feature between the Radarsat program and the optical programs is pretty obvious. They deal in optics, we deal in radar. The advantage that we have is that we can take images night or day, and we can do a much better job on ice and snow. Optical satellites look at it and they can't make the distinction.
What sort of sales are you expecting once Radarsat gets into operation?
Well, we're expecting over a 5-year period about $185 million in terms of U.S. dollars, which would translate into about $215 to $230 in Canadian dollars. We use that because the international community happens to make reference to the U.S. dollar. We would expect in our first year, 1996, hopefully we'll achieve around between $18 and $20 million. And then, of course, we would expect it to grow. We have a unique niche, which is nice. The problem or challenge that we have, if you will, is that because radar is a relatively new technology in the remote sensing industry, there is a lot of show and tell that we have to do. In other words, people believe it conceptually, they like the idea, but until they actually see it in operation, you can't expect to get a lot of advanced orders. We've had 1 or 2, and quite significant, I might add, but they're from the very, very sophisticated users who have used experimental radar data and know that it will work. I've said this recently to many others that it is absolutely amazing that a system that was designed in the late 70s and early 80s by the Canadian scientists and engineers will have no equal before the year 2002. They have done a fabulous job in designing a satellite that will be the world's most powerful and flexible, and as a result of it, complex, remote sensing satellite that the world has ever flown, except for military satellites, which cost 3 times as much, before the year 2000. And as we go around the world, which is where we spend most of our time, all over the world, the people in the remote sensing industry are tipping their hats to the Canadians over a great job that they've done. So we are quite different and quite forward thanks to the Canadian Space